All right, guys, we're back for more. We already have done the growth, which was day 5, and now we're going to be doing day 6, which is decay. What changed? The B. So for growth, B is greater than 1. Decay, B is less than 1, usually in the form of a fraction less than 1. We're not talking negatives, guys. We're talking about greater than 1 or less than 1. Negatives are about reflecting, okay? So that's something else. So horizontal asymptote is y equals 0. Domain is all real numbers. Range is still y is greater than 0. Now, what will change is your end behavior, okay? Because the end behavior is starting off high and then skating down close to the 0, okay? So again, a lot of things are not changing for this one. What is changing is where it starts, or where what the progression is. All right, so y equals 1/3 x. So if I plug in 0, I get 1/3. If I plug in if I plug in 0, anything to the 0 power is 1. When I plug in 1, I get 1/3. There we go. Now, what if I plug in -1? Well, what does that do? Well, that's going to change everything in here. So 1 to the -1 over 3 to the -1, well, that switches. So now, -1, I would get 3 as my answer, okay? Because, again, you're switching it because of those negative exponents. So -1 up 1, 2, 3, 0, 1, and then 1, 1/3. All right, so then, again, it starts off high and then goes low. And then again, it never crosses the y equals 0. It just gets smaller and smaller and smaller. Okay? All right, so let's look at these ones. So graph the following exponential functions, then state the domain and range. All right, we're going to plug in some points and kind of see what's up. So if I plug in -1, I'm going to get 2. Again, it's going to switch the denominator. If I plug in 0, I still get 1. Anything to the 0 power is 1. If I plug in 1, I get 1/2. Okay? Again, we want a few points so then we can kind of see what this thing looks like. Alrighty. Okay, starting off and then skating by. Domain, all real numbers. Range, y is greater than 0. Okay? If you want to keep plugging in points because you're like, my teacher needs more. Okay, plug in -2. So 1/2 to the -2 means 1 to the -2 and 2 to the -2. I flip it, so I get 2 squared over 1 squared, which equals 4. Okay, so -2, 4. So over 2 up 1, 2, 3, 4. I know some teachers have some awesome tricks to use. Just ask them what they do to figure these out if it's different than this, all right? So domain for the next one, all real numbers. Range, y is greater than 0. When we have 1/4, if I plug in -1, I get the answer of 4. When I plug in 0, I get 1. And when I plug in 1, I get 1/4. Okay, so graph those. Again, this is just kind of an additional part to what you did on day 5. Okay, that's why I'm moving a little bit faster just to get through this. All right, here we go. Now we've got an a involved. So I have a times b to the x. So I want to show you guys how you can, plug some of this information in and what does it mean. All right, so if I plug in 0, I only am putting the exponent attached to the 1/2, not to everything. So 1/2 to the 0 power is 1, and then 4 times 1 is 4. So when I plug in 0, my answer is 4. So where it is on the y-axis is a little bit different. It is shifted up, right? Okay, it's just because it's stretching. It is stretching what we're doing. All right, what if I plug in 1? Okay. So that's 4 times 1/2, which would then be 2. So I've got 1, 2. So over 1, up 2. All right. Well, what if I plug in -1? All right. If I plug in -1, what happens to this one? Well, 4 times 1/2 to the -1. How does that change? Move this up just a smidge. How does that change it? Well, it switches the second one. So 1/2 to the -1 switches to times 2. So then you'd get 8. So then -1 up 1, 2, 3, 4, 5, 6, 7, 8, all the way up there. Okay. Again, it's still going to skate by the 0, but it's just going to take longer to get down there, okay, just because of that factor. All right, domain, you can again write it like negative pi to pi, or again, the fancy r, which means all real numbers. Range is still y. Y is greater than 0. You can also write that 0 to infinity, okay? So again, it just depends on how your teachers want to write it. All right, now number 4 is getting more into it. Okay, so x minus 2. That means I'm going right 2. And this plus 2 means I'm going up 2. How does this affect it? Well, that's my horizontal asymptote, 1, 2. Okay? That's also what's going to affect my range. My range is going to be y is greater than 2 now instead of 0. You can also write it 2 to infinity. Domain doesn't change. Whew. Okay, so how on earth would we write this one? Okay, well, you want to see what kind of points you want to plug in and see if we can unfold it from here. Okay, so what if I plug in 2, all right? I want to plug in 2. So 3/5 to the second power minus 2 plus 2. Well, 2 minus 2 is 0. So I have 3/5 to the 0 plus 2. All right, let me just show you just this section so it's a little bit easier to focus. All right, so 3/5 to the 0 is 1. 1 plus 2 is 3. Okay, so when I plug in 2, I get the point 3. So over 2 up 1, 2, 3. All right, that's a point on the graph. Okay, what if I want to plug in, let's say I want to plug in 0 and see what happens. Okay, so if I plug in 0, I have 3/5 to the negative second plus 2. All right, well, what does the negative second do? Well, it flips this. So then I have 5 squared over 3 squared. Woo! Plus 2. Then I have 25 over 9 plus 2. Yikes-a-bee. So then we kind of have some gnarly fractions going on. Okay? So you kind of want to see what different numbers you can plug in to graph this thing. Again, it's a decay because of the 3/5, and then it's also shifted up. So plugging in different points and kind of see what this is. So if I plug in 0, I get 43 over 9. Well, what on earth? What is that into the calculator? So then, yeah, that's 4.7. So then you would go 0 and then up to that. So again, just plug some points in. Maybe you want to plot some points. Put this in your calculator. Just be really aware, guys. So you would want 3 divided by 5 in a parentheses to that, and then you'd also want x minus 2 in parentheses if you wanted to graph this, and then you would have that plus 2 if you want to see that in that calculator. Okay? All right, these are pretty tricky, guys. Again, where is it moving? What is shifting? And how does it affect it? All right, so this is meaning left 3, and then this would mean down 1. And what does this negative in front mean? Well, that's going to reflect. Okay, so if a graph is usually starting up high and then skating low, a reflection would look like this. Okay, so your graph is going to look similar to this one down here. Okay, so what is that going to affect? That's going to affect the range. The domain, still the same idea. Okay, the range, now instead of greater than -1, it's going to be less than -1. Okay, again, that's your horizontal asymptote, is that k value. All right, and then you want to plot some points, either graph it, get used to it, see what this thing looks like. So I'm going to plug in. Okay, so I plugged in some points. So I'm just going to give you an example of how I did one of them, just so you guys are aware of like what the operations are. So I'm going to plug in -3 and show you how I got the answer of -3. So I have -2 times 1/2, and then I have -3 plus 3 minus 1. So I kind of pick an x that's going to give me an exponent of 0. Okay, so I had 3, so I'm going to plug in the opposite. So I have -2 times 1/2 to the 0 power minus 1. Now, only the 1/2 is to the 0 power, guys. Okay? So 1/2 to the 0 power is 1, and then I times it by 2, and then I subtract it by 1. So you kind of want to do this part together. So -2 times 1 is -2 minus 1, and then that's how I got the answer of -3. Okay? So again, please make sure only the b has the exponent. So remember, a, b to the x, only the b has the exponent. So you want to deal with this part first and then times it with the a. All right? Okay, number 6. Again, what does +1 mean? That means left 1. What does -3 mean? That means down 3. What does that affect? My range. It's not reflected for this one, so y is greater than -3. My domain, again, all real numbers. And then you're going to be graphing that, okay? So, and then, again, you can have -3 to infinity. So we don't have any of these examples, but I just wanted to give you guys, just make sure you graph this one. Just wanted to let you guys know how would this affect end behavior, okay? So let's go back to number 4, and I'll talk about end behavior. Okay, so domain, for the most part, is all real numbers when we're talking about exponential. Range, again, is still greater than 2. How is decay different? Well, the end behavior changes. So I'm going to do end behavior for number 4, just in case you need an example, all right? And then we will be done for today. So when x is approaching infinity, what is f of x approaching? Okay, so as x is getting bigger, what's happening to y? When it's a decay, y is getting closer to the horizontal asymptote, okay? So f of x would be 2. Now, when x is approaching negative infinity, what is f of x doing? Okay, so when x is getting to become negative, what's happening to y? Oh, to y is getting bigger. So f of x is approaching infinity. So that is the difference, okay? So these would be swap-swapped when it's growth. Okay, when it's growth, it's getting bigger on the right. When it's decay, it's getting smaller on the right. All right, so thank you so much for joining me on exponential decay, and I hope you guys are having a great day. Goodbye.